We're looking at how trig functions, sine, cosine, tangent, and others, are related to the unit circle. Now in this video we're going to get into common trig values, and the key there is finding the triangles, looking for the triangles in the unit circle. Now here's what I mean. So here's the unit circle, and it's a diagram I use often in this video series. And if the question is what is the value of the cosine or the sine or even the tangent at certain angles, well, there's two things you have to figure out. First of all, what kind of triangle are you talking about, and where is the sine and the cosine in that triangle? So first of all, let's say that we're looking at a 30-degree angle on the unit circle, which of course is pi over 6, same thing. And we're going to be having an endpoint on that hypotenuse at right here. Now the idea is it's a right triangle, and if you draw a vertical line right there and another line right there, we have an x and a y value, right? It's a right triangle, just the way we've drawn that angle. Okay, so we have a 30, 60, 90 triangle, and we have a x leg and a y leg. All right, let's see what happens when we look at that 30, 60, 90 triangle. In that kind of triangle, a 30, 60, 90 triangle, because we know this angle is 60 degrees, there's certain relationships that the legs have with the hypotenuse. Now because we are coming from the unit circle, we know that the hypotenuse is one whole unit long. Obviously that's the longest side of this right triangle. The vertical part and the short leg of this triangle is the y value, and the horizontal part is the x value. Now, knowing what we know about sines and cosines, remember that if we use the 30-degree angle as a reference angle, the opposite side, which is where I have y, over the hypotenuse, so y over 1 equals sine. So the sine value is the vertical or the y leg. All right? In a unit circle triangle, the vertical leg is the sine. The horizontal leg is the cosine. All right, now that's true no matter what angle we're talking about here. So that's something you have to kind of keep in mind. All right, the vertical part is sine. Wherever you're going to go up and down is the sine value, and the left or right part is the cosine. Now that relationship is going to be true no matter the orientation of these 30, 60, 90 triangles. So if I look at these three examples here, the hypotenuse is always going to be 1 no matter where it is and the way the triangle is oriented. The vertical leg is always the sine, and the horizontal leg is always the cosine. Alright, so notice how it looks when we look at the rotations of these three 30, 60, 90 right triangles. Now that is key to figuring out trig values at different angles on the unit circle. But what are those values of the sine and cosine legs? Well, because of the Pythagorean theorem and the fact that the hypotenuse is 1 and just the relationship between the legs and the hypotenuse, this is always going to be true. The shortest leg of the right triangle, so it's opposite the 30-degree angle, is always 1/2. Okay, it's always half the length of the hypotenuse. And the longer leg is radical 3 times longer than that, so it's going to be radical 3 over 2. All right, now these are probably some values you're going to have to just memorize. All right, so across from the 30-degree angle is 1/2. That'd be vertical here in this case, the sine value. The longest leg, which is opposite the 60-degree angle, notice how it's longer, is radical 3 over 2. So in these examples here, the sine values are always 1/2. Notice how it's the shorter leg. Here though, it's the cosine value, the way the triangle is oriented. The longer leg is always radical 3 over 2. Alright, now that is going to tie into when we go around the unit circle and look at radians and degrees of certain angles, we're going to be able to figure out the trig values. So let's take a look. So for this 30-degree angle, which is pi over 6, we notice that the vertical leg here is the sine and the horizontal leg is cosine. And in these ordered pairs here, we're at the end of the hypotenuse point. Notice how it's cosine followed by sine, just because of the way the triangle is oriented. So if I'm looking at this leg right here, that is obviously 1/2, and that's the sine value. Okay? If I'm looking at this vertical part here, then that is the cosine value. Alright, so it takes a little bit of time, but in trying to memorize the shapes and the legs of these right triangles, the key is to remember cosine followed by sine. Okay? Horizontal followed by vertical. Let's look at a 60-degree angle. So we go from here to here, and that's my hypotenuse. Notice 60 degrees is the same as pi over 3 radians. Now, if we construct this right triangle, then I can look at my sine and cosine values. The cosine value is here, which is 1/2. And the sine value is this vertical leg here, which is radical 3 over 2. Again, several points to emphasize. This is a 30, 60, 90 triangle, and the relationship is always short leg is 1/2. In this case, that's this distance here, and that is the cosine value. Always comes first in the ordered pair. And the vertical leg here happens to be the longer leg of that kind of a triangle, and it is radical 3 over 2. So short leg is 1/2, long leg is radical 3 over 2. Cosine gets listed first. That's the horizontal part, and then the vertical part, which in this case is the longer leg, radical 3 over 2. There are all kinds of 30, 60, 90 triangles in this unit circle diagram, and here's another one. Let's say we go out to 120 degrees. We open it up this wide, and notice how I can make this right triangle again 30, 60, 90. So there's my short leg, that's the cosine value, and the longer leg is the sine value. So notice how the cosine value is negative though, because we go back here. Alright, notice how it's negative 1/2. And radical 3 over 2 is this vertical part. That's the sine value, radical 3 over 2. Hey, here's another one. Okay, notice how we can make another right triangle. And the short leg here is a negative on the y-axis there, and that's negative 1/2. And the longer leg is radical 3 over 2 because we're going this way on the cosine value, okay, going backwards on the x-axis. Alright, and of course here's another one. So anytime you have a 30, 60, 90 triangle, and there's a lot of them on this unit circle, you have that kind of relationship. Alright, so let's look at that point. Well, you're going to go out this way, positive direction. That's the short leg distance. That's 1/2. That's the cosine. Then here is the sine value, negative radical 3 over 2. That's this distance going down this way on the y-axis. Alright, so if you can just focus on 30, 60, 90 triangles, and you know the short leg is 1/2, the long leg is radical 3 over 2, then you've got it. Now in the next video, we're going to be looking at 45-degree angles. Okay, those are some isosceles right triangles that also show up on this unit circle. Then we'll do some problem sets to practice. Thanks for watching this video.